And we are live. So this means session starts. Good morning, everybody. I welcome you all to today's oral presentation session at the Tropentag 2020 on ruminant systems. My name is Christian Hülsenbusch. I have the honor to be the chairman of this session. And before we start, I will briefly tell you a little bit about the technical setup. As you all know, the attendants that are not immediately part of this session are viewing this session on a YouTube live stream. And at the same time, if you have opened the YouTube live stream in a YouTube window, you can have the Wova platform window of this session also open, and this permits you to ask questions in the session Q&A section. So while the speakers are speaking, you will have already the possibility to ask your questions, and you will also have the possibility to vote questions that you consider most relevant up. So these questions will appear here on my screen, and I will present them to the speakers, and I will also invite the speakers to question themselves interactively. So we have 5 presentations this morning. 4 of the speakers are with us. I greet Maria Wurzinger, who is originally from the University of Vienna, but right now she's in Latin America at 3 o'clock in the morning. I greet Flora von Steinke, who is with us in Witzenhausen, Marion Reichenbach, who is at the University of Göttingen, and Salma El-Zaki from the Humboldt University in Berlin. And we will start straight away. The first presentation of today is by Marion Reichenbach on differences in carbon footprint of dairy production systems in the rural-urban interface, and she will take us to India. Marion, please, the floor is yours. Share your screen and give your presentation.
Okay, good morning. Oops. Now, do you see my presentation? Oh. Hello? Because I don't hear you anymore.
Yes,
okay.
I can see your presentation, but I have muted my microphone so not interfere with you.
Okay, so I'm all good to start. Yes. So good morning, everyone, and welcome to my talk on difference in carbon footprint of dairy production system in the rural-urban interface of Bangalore, India. It's a long title, but I hope the topic will interest you. So before starting, I would just like to precise that, of course, this work was not done alone. So I thank my colleague for their inputs. And this work was funded by TFG in context of the research unit for 2432 on social ecological system in the Indian rural-urban interface. So first of all, why am I talking about carbon footprint of dairy production system and urbanization? So most of the tropics today, they are urbanizing, especially with West Africa and India being urbanization hotspot of the next decades. And what happened is that actually urbanization affects resource availability. If you are a dairy producer in a rural area, you have a lot of land available to cultivate your crops and keep your cattle. You also have most of your household member working with you on the farm because there is no other job opportunity. But if you are getting in an urbanizing environment, there is less and less land available for you to cultivate or keep your cattle. And also people of your household might be interested to work outside the farm because they get better job, it's better paid, it's more easy. So you get less resource. And this directly affects the production strategy of the dairy producer. So according to the resource he will choose either to intensify production or maybe extensify production. And this is where we come to carbon footprint, because carbon footprint is a direct consequence of the production strategy of the producer. How much resource he is using and how much milk he is producing will define its carbon footprint. So there is a long but clear or important relationship between urbanization and carbon footprint. So my research question aimed to directly test this link in the case of Bangalore, India. So does the carbon footprint of dairy production system in Bangalore, India differ according to their location in a rural-urban interface and or intensification level? To answer this question, again, I went to Bangalore. It's a mega city south of India, 10 million inhabitants, and it's urbanized very fast along the last 20, 30 years. On the map, you can see the two research areas that were actually established by the research unit, and every square is actually one settlement where I worked. So you see some of them are in the city, so they are really urban dairy farm, and then you have peri-urban and rural one. In this research transect, I previously identified 4 dairy production systems, and you can see the first production system is actually ubiquitous. So that means it was present along the whole transect or the whole rural-urban gradient. And dairy producer there, they relied on pasture, but they did not cultivate their own forage. They rather send the cattle to pasture, and then they also collected forage from public places or organic waste from the neighbors or from the neighbors or from markets. So it's a very extensive system because they don't use so much land or labors. They just get the forage. They don't cultivate it. Then system 2 and 3 are rural system, and you can see there they send the cattle to pasture and they cultivate their own forage. So both were semi-intensive system. The difference between the two systems is actually how much cattle they keep and which kind of cattle, the quality of the cattle. In system 4, we classified it as a very intensive system because the dairy producer did not send the cattle to pasture. They cultivate all the forage that they gave to the cow. So of course, it was a lot of work and a lot of land needed for this production system. For each, overall, all the farms, however, were small scale and family. So the people kept between 2 to 5 cows, more or less. For each system, I selected 6 farms, and then in total, I worked with 24 farms to do this analysis. What I did is that I visited each farm 8 times at 6-week interval over a year, and I looked at everything that the cow was eating and everything that she was producing in terms of milk and manure. So this gave me a lot of data, not so much cattle because they kept few animals, but over the year I had still more than 800 data to do my analysis. So usually a carbon footprint is assessed through a cradle to farm gate life cycle assessment. So this really computes all the emission emitted during the production of an output. So when 1 kilo of milk is produced, how much greenhouse gas emission is emitted. But because of my data, I actually focused only on the emission directly related to livestock. So my carbon footprint is actually a partial carbon footprint. I calculate all the emission due to enteric fermentation, the methane emission due to manure management system, and the indirect or direct nitrous manure management system. I calculate it following the 2006 IPCC guideline, and this gives you the greenhouse gas emission, and then you have to relate it to how much milk is produced on the farm, which is actually your carbon footprint. So, to come for the result, first I want to show you the methane emission. So on the side, you have actually the enteric fermentation, and then in the middle, the methane due to manure management system. And this is all greenhouse or methane emission emitted per farm and per round. So this is a 6-week interval. You can see it's not the same scale between the two, but you have exactly the same pattern. So you have system 1 and 2, which are very low emitters, and system 3 and 4, which have very high amount of emission. And this is because in system 3 and 4, they were actually oversupplying their cattle. They were giving way too much of forage, which is quite surprising for a tropical country. And the forage was of average quality. In system 1, they were giving little forage, but some cattle were undersupplied, but it was rather close to the requirement of the animals, and the diet was of very high quality, so you have low emission. In system 2, they were giving little forage, but of average quality. And now, if we look at the nitrous oxide emission due to manure management system, again, we have the same pattern. Because if you feed your animals a lot, then they produce also a lot of manure, and then you get a lot of emission. However, this is just the greenhouse gas emission, and to get the carbon footprint, we have to compare it to the amount of milk produced per farm. So you can see system 3 and 4, they had in average a little bit more, they were keeping a little bit more cattle, and they were producing a lot of milk over the year. In system 1, they were producing average, and system 2, they had the same number of cows than in system 1, but were producing less milk. And this gives us very interesting carbon footprint. So here I just divided the greenhouse gas emission by the milk production. And you can see the best system, the most environmentally friendly system is system 1, where they produce 1 kilo of milk. For every kilo of milk they produce less than 1 kilo of greenhouse gas emission. So it's a very good system, and it's better than the 3 others. And this is because they had low emission and a relatively average milk production. In system 3 and 4, they had very high milk production, but also high emission. And these high emissions are actually not compensated by milk production. They're not efficient enough in milk production to have a low carbon footprint. And in system 2, they had low emission, but they also had low milk production. Then the carbon footprint is not so good. So you can also really clearly see here the link between greenhouse gas emission and production. Okay. So to conclude my presentation, yes, there is a clear link between urbanization, intensification, and carbon footprint in the case of Bangalore. And we can say that urbanization leads to both intensive dairy production system with a high carbon footprint because they were very inefficient in their feed supply. But at the same time, it's led to an extensive dairy production system with a low carbon footprint because the dairy producer really relied on a specific resource available through the neighbors and through the market. So this organic waste actually have a very high digestibility. And since they get it from outside, they can also not get huge quantities. They get enough to feed the cattle, but not too much. So they feed high quality and according to the diet. And at last, I think this work also shows the importance of local assessment, which account for local perspective on constraint and opportunity in an urbanizing environment. Because from a European perspective, we would always think, okay, systems which are more intensive produce more, they are more efficient, they are more environmentally friendly because there is higher milk production. But in the case of Bangalore, that was the opposite. And there is really a lot of surprising thing that we didn't thought about it. Collecting organic waste, this is not something we do here. And this is actually an interesting strategy for the dairy producer in Bangalore. And on this, I'm finished. Thank you very much for your attention. I'm happy to take any question.
Thank you very much, Marion, for an interesting presentation on and I welcome Zeyi. Hi, Zeyi. We are
Hey.
Good to have you with us. So we are complete. Marion has just finished her presentation and I invite questions. While everybody is thinking, I'm reading the first online question to Marion, and that reads, did you present your results to the milk producers? If yes, were there any reactions? Did they understand the need of your analysis? And how do the Indian policy makers react? That is a question by Andrea Fadani from Foundation Fiat Panis.
Yeah, it's a very interesting question. And we did a feedback round with a farmer we worked with, but I hadn't done the carbon footprint analysis yet. So what I did before was a feed efficiency analysis, and it really showed this oversupply of cattle. So when we did the feedback round with the farmer, we really tried to insist on differential feeding, that they should really feed their cattle according to their requirement, because they were just giving forage to the lactating cow and to the dry cow the same amount. And then what we did was to distribute them a small, like kind of this parking thing that you can change the hours, but there you could put like how much milk the cow was producing, and then it was giving you an indication of how much forage you could give to the cattle. And the farmer were really happy to receive it, because I mean, it's usually assumed in the tropics, cattle don't have enough forage. And in Bangalore, we already arrived to the state, okay, they are feeding enough, and now they should focus a little bit more on the quantity and the quality of the forage. And the farmer were really interested in doing that. So yeah, that's, and for policymaker, I mean, we didn't had contact with policy, but I think this work could really be used for supporting urban dairy production in India. I mean, it's very common, and they basically are very informal, while there is a lot of advantage. I mean, right now, also in time of Corona, to have a neighbor who produces milk, when you drink 1 liter of milk every day, it's quite useful. And I think it's really also people that need to be integrated in the city and need to be supported. And this kind of study will show that they are actually quite efficient, and that they are also making a service by recycling organic waste is important and should be taken into account. But here I was just a natural scientist. I didn't want to the next step. So.
Okay, so as far as I understood your answer, then your research initiated sort of the demand on the side of the farmers for advice on feeding cows more in relation to the nutritional requirement according to the milk production level, which is already quite something. Are there any questions from the panels, from the other speakers? If that is, Maria, yes, come on.
Just for clarification, Maria, first of all, I really liked your presentation, but you always talk about forage. Was there also concentrate fed to the cows? And did all farmers produce themselves, or did you also purchase forage?
Yeah, that's just a misuse of the English word. Yes, it was concentrate. So there was organic waste, the concentrate. There was also straw that were used, and the green forage, different types. So I really spent the whole day on the farm, and every time that the cow was getting something to eat, I was just writing it down, measuring, taking sample, and so on. So this is also accounting for concentrate. Concentrate, they always get it from the dairy cooperative for a subsidized price, and then they give quite a large amount. I mean, all the cows receive 3 or 4 kilos per day, so it's quite good. And then the green forage, most of the farmers cultivate it themselves, because then they don't need to pay anything. And a few producers bought it, but it was rather a richer farmer. And this is where it's become interesting. It's that a lot, or not a lot, some dairy producers, they didn't bought anything, and they still kept cattle, because they send the cattle a lot to pasture 8 hours a day, and then they were giving the concentrate that they were paying for. But then in terms of green forage, they were collecting it from lake, for example. In Bangalore, there is a lot of lake, and then you have grasses growing around, and the farmer just go there and collect 10 kilo for the cows, and then they start again the day after, or they get organic waste and so on. So it's an interesting thing. It's that they are very resilient, and they just get forage from around. So, yeah.
Thank you. And I have another online question asked by Macarena San Martin. Which solution could be possible to implement the reduction of the emission during this process? I mean, you have partly already addressed this in the previous answers, but can you sort of pin it down to a placative sort of statement?
Yeah, so I must say, to really be fair, the whole cradle to farm analysis or carbon footprint should be calculated, because this is really directed to livestock, and to really bring a change, this should have also stronger numbers, so a complete analysis. But I would say, I mean, the use of organic waste, we should speak about it more. I know that also now with this notion of circular economy, I mean, it's coming a little bit more. So it's also a nice way to recycle something would be otherwise thrown away in the tropics, and maybe could be supported to other dairy producer in India or in other tropical country. And then I think the main thing would really to support the dairy producer, which are already doing it, because I mean, they are already efficient right now. It's already a very low carbon footprint. But most of the people think, okay, produce milk in the city, it's a strange idea, we should not do it. And I think this is where there is the biggest work. It's to make it more known, and also to support the people who are already using this practice. And this doesn't need to be put in contradiction with intensive farmer. Both are possible, and like just that they use the opportunity that they have, because also rural dairy producers, they won't have that much organic waste, for example, available. So for urban producer, it's a solution, and they should be supported as a producer, and then they will continue to use this opportunity and to be environmentally friendly. That's, yeah.
Yeah. So thank you very much, Marion. And I think the time that we have allocated for the first presentation is up. With this, I thank you very much again for your presentation and for addressing the questions. And now we shall move to the second presentation, and that is the one of Sei Fridayus. And I'll ask our technology host to start the video that he has sent.
Good morning, everyone. I am Sei Vanvanhosu, PhD student at the University of Gießen. I'm happy to present you my work entitled Genetic Characteristic of African Breeds, an example of multi-breed GWAS for morphometric traits in Beninese indigenous cattle. I will start with the background and aim of my study. Then I will present the materials and method, the result and discussion, and finally the conclusion with some perspectives. In Benin, like other African countries, indigenous breeds represent valuable animal genetic resources. They are basis of livelihood for millions of farmers, and they have unique adaptive traits such as resistance to disease, tolerance to feed and water scarcity. Unfortunately, these valuable resources are threatened in Benin by crossbreeding and climate change, while they are not sufficiently characterized. These are the 4 indigenous breeds in Benin: the Taurine, Somba, and Lagoon, the hybrid Borgu and Pabli. Phenotypically, the hybrid animals are bigger than the Taurine. The main challenge for the characterization and better management of African animal genetic resources is the possibility to collect sufficient and good data on animal performances, as no data collection system exists in health. In this condition, morphometric traits represent potential alternatives for animal evaluation, as they are easily and accurately measurable, and they are associated to animal body weight or animal health. The aim of this study is therefore to use morphometric trait and genomic tools to improve our knowledge of Beninese indigenous cattle breed, by estimating genetic parameters and identifying functional loci underlying the variability of morphometric traits in these spreads. 6 morphometric traits, height at withers, sacrum height, head girth, hip width, body length, and ear length, were therefore recorded on a total of 449 animals, considering the 4 breeds. The animals were genotyped, and genotype data were submitted to quality control, genotype imputation, and LD pruning for some specific analysis. Age, sex, agroecological zone, and breed were included in the model as environmental feast effect. We have also corrected for population stratification using linear discriminant function from DAPC. In the other hand, we estimated heritability, phenotypic, and genetic correlation using restricted maximum likelihood method in GCTA. The multiple GWAS were performed in Plink using this model, and significant SNPs were assessed using a genome-wide Bonferroni threshold and a chromosome-wide threshold to be less sensitive. A window frame of plus and minus 25 kilobase around with SNPs were used to map potential candidate gene, and these genes were annotated in the DAVI database to identify pathways and biological process in which they are involved. Now the results. The heritabilities estimate for the 6 morphometric trait range from 0.22 for head girth and 0.74 for heat waves. Genetic correlation were between 0.14 and 0.85, while phenotypic correlation ranged from 0.25 and 0.89. These values were higher than those obtained for conformation traits, but it was similarly observed in the literature that genetic parameters are higher for morphometric traits than for conformation traits. In addition, our values were comparable to those obtained in previous results for morphometric traits. The inclusion of linear discriminant function in the GWAS model resulted in sufficient population stratification as showed by the Landers values, which were between 0.99 and 1.09. 1 genome-wide significant SNPs and 5 chromosome-wide SNPs were associated to head at withers. The genome-wide significant SNPs have been previously reported for recoverability from mastitis in cattle. Another SNPs were reported for feed efficiency. Near the SNPs, we mapped 4 candidate genes which were previously reported for carcass threat, body cells, or antibody response and feed intake. 2 chromosome-wide significant SNPs have been reported to be associated to sacrum height, and there were near 2 candidate genes which were reported for body size or fat content in cattle or response to stress in previous studies. For hot guts, 4 significant genes were associated and 3 genes were mapped near these SNPs. 1 gene have been associated to morphometric traits, while the other one have been reported for immune response or heat stress in previous studies. 3 significant SNPs with 1 gene have been associated to heat waves, and the gene were previously reported for back fat thickness, feed intake, and immune response in previous studies. For body length, we identify 1 chromosome 1 SNPs and 1 genome-wide significant SNPs and 8 chromosome-wide significant SNPs associated. Near these SNPs, 4 genes were mapped, and they were associated to fat deposition, height, feed efficiency, or immune response in previous studies. For ear length, 4 SNPs were associated with 2 candidate genes, including the METF11 that we found for body length. The second genes were also associated to body weight, inflammatory response in previous studies. To sum up, we estimated irritabilities, phenotypic and genetic correlation for 6 morphometric traits, and they are moderate to moderately high. We have also identified a total of 25 SNPs with 15 genes associated to the 6 morphometric traits. These are relatively few, but may be explained by our small sample size. Nevertheless, the gene function and the comparison with the literature give enough evidence for the validity of our results. It was also interesting to find that the detected genes are associated to immune response and feed efficiency, which is in line with the evolutionary development of the indigenous traits and may suggest a strong correlation between morphological and adaptive traits. Finally, our study presents the potential of multiple GWAS in detecting precise functional loci across breeds, and this opens different possibilities to investigate unstudied indigenous breeds in Africa. We are at the end of my presentation, and I thank you for your attention.
Very good. Thank you very much. Can everybody hear again? Yes, I see nodding faces. So the floor is open for questions. Does anybody have questions?
Yeah, I have one question.
Yes, Maria. Welcome.
Okay, thanks for nice presentation. Just can you clarify what you mean by hybrid cattle?
Hi everyone. Hybrid cattle means the cattle that were a crossbreed between taurine and Andean breeds. So the bog and the pablo has been described like a result from crossbreeding.
But it's an old crossbreeding.
Yes, it's an old crossbreeding. Of course, we have made also other results, and we saw that there are again new crossbreeding in the same population, but there are different populations in this Borgo. So there are all these breeds are established as old result of old crossbreeding, but now they are still crossbreeding as I described in the presentation.
Yeah, thank you. As far as I understood, basically you have established the heritability of those linear body measurements that you have, and you have located that heritability, if you so want, on the genome somewhere. This is what you did with your SNPs. Now you know which gene is responsible for doing that. And then you have also determined via your correlations, positive correlations of these body measurements with body weight, with immune response, and so on. So would you consider that this could now influence breeding strategies? How could farmers make use of your information?
Yes, thank you very much for your question. I think we are at the beginning of the research on those breeds. As I said, they are not really studied. So we are looking for a way to improve our knowledge. Of course, the final goal is to establish breeding strategies. But before doing that, we need to have information like performances and also genomic information on those breeds. But to do that, we also need information of the animal performances, which is very difficult now to get with the breeding system. So these studies open that it's also first to find out that it's possible to characterize, to use the morphometric traits to have information on this animal. So for instance, if with the correlation that we found between body morphometric traits and also body weight, which is like a production result, like a weight gain, we can then know how we can select animal to improve body weight in these animals, or also if you want to improve the breeding system, because it was interesting to find that there are correlation between immune response and body and morphometric trait. So it will be possible to select animals that are more resistant using morphometric trait information. So we don't need anymore to collect information on resistance, but we can use the indirectly information from morphometric trait to select animal, and that is the goal of our study.
This is very cool. And my question was just to pave the floor for the first online question that we received again from Andrea Fadani of Foundation Fiat Panis. Thanks for following us, by the way. And the question is, are farmers aware of these positive characteristics of the indigenous breeds in Benin? And are farmers, if I may add, are farmers aware of the association or correlation that you have found between the traits that you have measured and the other traits that are adaptational traits?
Yes, this is also a nice question. The farmer know that the animal are resistant to disease or also to harsh condition. And that's why some of them still keep those animals, because those animals right now are not good productive like other developed breeds in Europe or in other countries. But because the farmers can keep this animal even without a lot of food, a lot of water, they try to keep them. They try to produce a small quantity of milk with these animals, so they know the abilities of the animal for resistance, but they are not aware of the correlation between morphometric traits and this adaptive traits. And this is the result of our research. And this finding will help us now to improve, like we can help now from this result. And of course, from those other studies that will follow, we can then help farmers to improve their production system. And also we may think about breeding system to select animals, as I said before.
Okay, thank you very much. I have one more, a little provocative question. Now, not all of these animals have the same degree of resistance, and not all of them have the same good immune system, whatever. Now, you have developed sort of a crutch, if you like. So you take body measurements to represent resistance. This is something that allows you as a scientist to see which of the animals is more resistant due to that correlation, right?
Yes.
So now, has the farmer maybe other characteristics that he knows in the animal? The farmer will probably also be able to tell you, this animal is more resistant, that one is a bit weak, this other one is intermediate. And did you find out somehow what farmers are looking at to breed for resistance?
There are farmers, they have a lot of knowledge also to select animals. And this is also some perspective that we are trying to investigate. What is really known for the resistance is animal colors in cattle. Some farmers, they can look on the animals' colors to guess when these animals may be select for breeding. This is possible. But of course, they also observe the animal body to select them. The animal sometimes it's not like a fixed characteristic like I can establish in research.
Mm-hmm.
When they look on the animal and they see the how the animal is robust, they can say, yes, this animal may be a good producer of milk, or this animal may be a good maybe resistance for disease or other things. But these are just like knowledge that are not really investigated to be used in research.
Okay, thank you very much. I could carry on with this discussion for at least half an hour, but we have arrived at 11:10, and I think it is time to switch to the next presentation. So thanks again for your nice presentation and for answering the questions.
Thank you very much too.
And I now call upon Flora van Stanker, to give us her presentation of feasibility of organic certification. And she will take us to northern Kenya, where we will get acquainted with sheep and goats. Flora, the floor is yours.
Thank you.
And thanks.
Welcome to my presentation of with the topic feasibility of organic certification of sheep, goats, and camels produced in pastoral systems in northern Kenya. First, I will give you some background information. In Kenya, the pastoral livestock production has a high economic value. So in northern Kenya, sale of small ruminants is the main regular income source for more than 2/3 of pastoralists' households. Despite the importance of livestock marketing in these areas, the current livestock trade is not very profitable for pastoralists and local traders. The marketing is hampered by several factors. The sheep and goats are sold in undifferentiated commodity markets without direct links to end buyers. Due to this missing link, the producers and traders don't know the demanded qualities and quantities. Additionally, there are volatile prices in the different terminal markets. So although the small ruminants produced in northern Kenya are preferred in the domestic livestock market due to their meat quality, there is currently no economic advantage for producers and traders from it. But it might be an opportunity for other ways of marketing. And this is where branding and labeling comes in. Product labeling could pave the way to firm contracts between producers, local traders, and final consumers, and it enables a shift from a commodity market to a niche market. So this can be implemented in form of a geographical indication or in form of an organic certification, for example. And we decided to assess an organic certification, and I will show you the reasons why. So first of all, there was a previous study in Iran where the pastoral goat and sheep production was found to be in accordance with requirements of organic certification. So the effort for conversion from a nature-based pastoral system to an organic production system might be low. Additionally, organic certification has high demands on the process quality. So many areas of the livestock production system can be examined, and the gained information can be provided for other types of labeling and branding, for example, for geographical indication. So the objective is now to assess the requirements and the feasibility of organic certification of the pastoral livestock production to establish a value chain for branded products. The specific objectives are first, to assess the compliance and the non-compliance of pastoral livestock production with organic standards. The second objective is to assess challenges in fulfilling requirements of organic standards and of group certification, and to develop ideas to overcome these challenges. The study location was in the south of County Marsabit in the sub-county Laisamis in northern Kenya. There is an arid landscape which is prone to droughts. The population consists predominantly of pastoralists of the ethnic community of Rendille. They raise livestock on communal land for income through sale and use the natural rangeland as the main source of forage for their animals. In this area, there are high illiteracy and poverty levels and a poor infrastructure. The fieldwork took place from August to October 2019. I applied a collaborative learning approach in which the focus was on mutual learning. The qualitative data collection was done via focus group discussions with 4 pastoral community groups. They were all from the ethnic community of Rendille. They were mostly women and they were all engaged in livestock trade. Together with the field assistant, I introduced requirements of organic standards and of group certification via self-drawn posters. And in the following, we discussed these requirements. Further, 2 multi-stakeholder meetings and 21 individual interviews with further stakeholders were carried out. Now I will show you the results and also discuss it. So the first objective was to assess the compliance and the non-compliance of pastoral livestock production with organic standards. Organic standards are based on the following principles of organic livestock production. So first, animal welfare and the management that allows natural behavior of the animals. Also, eco-friendly and health-promoting feeding and natural veterinary treatments that do not endanger the human health in some way. So compliance is where the nutrition of the main herds, because it is based on natural vegetation. Then the housing, because the herds live in open rangeland and have unlimited space for free movement. And the reproduction, because it is based only on natural mating. The second objective was to assess the challenges to meet requirements of organic standards. And as organic production requires an eco-friendly and health-promoting feeding, the use of the imported supplemental feeds for the home-based animals during drought are a challenge because there is risk of forbidden ingredients in it, for example, like hormones or genetic modified organisms. Mutilations without painkillers are a problem for the principle of animal welfare, and mutilations are carried out, but painkillers are not available in those areas. So ear notching and hot iron branding is carried out for the purpose of identification, and it also has a cultural value as it shows clan affirmation. And then another mutilation is the castration. It is done for better meat quality and it avoids injuries and stress on the herds and neighbor conflicts. The extent and the frequency of conventional veterinary treatments is not known. There's an information gap. So it is not possible to assess whether the requirements of organic standards can be met. But the limited veterinary infrastructure might be a challenge because the pastoralists are doing a trial and error method in the veterinary drug use. And there's also a lack of vaccinations which could prevent some diseases. Another challenge is in the traceability because there are no formal livestock identification and traceability systems in place. And to control compliance with organic requirements, traceability and also records are needed. Currently, written records about the livestock production are not kept by the pastoralists due to illiteracy, additional work, and the mobility of herds. The third objective was to develop ideas to overcome these challenges. in terms of mutilations, an exemption by the certifier is needed for cultural practice, or otherwise ear tags could replace the traditional identification marks. But in every case, painkillers must be made available by a well-developed veterinary infrastructure, for example. In terms of veterinary treatments, a study should be conducted on the current veterinary drug use of the pastoralists and about drug residues in livestock products. Vaccination should be extended by informing the communities about the benefits of vaccination and by training veterinary staff in an adequate communication with the communities. Visible ear tags should be introduced for the traceability. And in terms of record keeping, innovations should be developed for illiterate people and for mobile herds. For example, pictures could be taken of relevant events. We also assessed requirements of group certification, which allows smallholder groups to share certification costs. One challenge is the project initiative, because support from outside is needed in terms of financial support and also in producer training. Another challenge is that the inspections of the mobile herds are time and cost intensive, because in the dry seasons, the main herds are hard to reach due to distance and they are in inaccessible areas. And in the wet seasons, some roads are not passable, as you can see in the picture. Ideas to overcome these challenges are that the project initiative is supported by an NGO, or that a production for a marketing partner is implemented who is interested in marketing organic meat. In terms of inspections, the high costs of the inspections must be weighed against the benefits of organic certification, so there is no satisfactory solution. So the conclusion and the recommendations are now to start, instead of organic certification, with a geographical indication. Because the sheep and goats from Massabit are already preferred due to their taste, and labeling the origin could facilitate the marketing. The next point is that meeting the organic requirements is not as easy as the iron study I described in the beginning implied. So therefore, the community groups wished for less strict requirements. For example, challenges in avoiding mutilations may endanger an organic certification. Lower requirements would also make the inspections easier to carry out, and a GI could implement a basic infrastructure in terms of ear tags for traceability or innovations for the record keeping. And if this basic infrastructure is in place, it is possible to move stepwise to organic certification. So thank you for your attention.
Thank you very much, Flora. And now if you stop sharing your screen, maybe, then I'll invite questions. Who wants to go first? I can't see everybody.
Okay.
Yes, I have a question.
Yes, Ziggy. All yours.
Okay, thank you, Flora, for your presentation. I am very interested by your research because I know the condition for organic, the challenge for that in Africa. And my first question is there already some community group that sell the meat in the region that you study?
There are some income generating groups, mostly women groups, and they do the marketing of their small stock together. So yeah, so they are registered as income and self-helping groups, and yeah, they do it together, and there are many of them. I think in whole Massabit, over 100 of these groups. Yeah.
Okay, the second question is, have you discussed with them whether it's possible to use ear tag? I
asked them about the ear tags, and the women themselves, they have seen it, but currently, yeah, it's not implemented. And they were a bit skeptical about it because they can't read the numbers because of their illiteracy. But I think it is possible, to teach them or to train them in the implementation. And there also have been studies in that area, not on goats and sheep, but with cattle. And there they had good results in the introduction of ear tags. So,
okay.
So there have been some smaller project, but it's not introduced in a wider context.
I'm asking that because I know that in some regions, there are farmers that are skeptical by using that. Like there are some sociological background by using this ear tag or other way to identify animals. So I don't know whether it's possible with this group. That's why I'm asking that. So this is also maybe taking account. I don't know how they accept this new technique. But finally, I know that's one challenge also is the feeding. Of course, it's natural vegetation, but sometimes farmers also use the animals graze on farm, like agriculture farm. And some agricultural farm, they use other product to treat the farms, like herbicides and other things. And taking this account, I know that there are some companies that when they assess the condition, they don't accept that the animal product is organic because of this condition. What do you think it, or have you also think about it in the area that you have make your study?
So in that area, pastoralism is the dominant livelihood activity, and therefore on the whole communal land, herbicides are not used. So we asked them, do you know them? And they told me, oh, we don't even know how to apply it. How can we use it? So in that perspective, it was not a problem. Yeah.
Okay, thank you.
Yeah.
Introduce the first online question, again by Andrea Ferdani. Do you have an estimation of the involved cost when organic certification would happen? What can you say about the cost of certification?
So the research was not so much about the costs. I remember did some research on the certification costs. And I think it was per group about 500 up to 1,000 euro per year. But I'm not so sure about it. So there was not a focus on the study.
And do you yourself have knowledge about different forms of certification that would come at different costs? Like for example, certification by an accredited certifier, then forms like smallholder group certifications where you don't certify the individual farmer, but a whole group of farmers or a cooperative, or participatory guarantee systems where farmers cross-certify each other.
So first, we just discussed the requirements of group certification in terms of implementing an internal control system. But we also talked to organic organizations in Nairobi, and one also recommended to start with the PGS. So if you have a marketing partner, that you implement first a participatory guarantee system and then go step by step to an internal control system. So yeah, it was a recommendation, but we focused on the requirements of an internal control system.
And the women groups involved, what did they think about the feasibility of something like that?
So they were skeptical because of the project initiative, because of the cost. And also a problem was the illiteracy level of the people, because for an internal control system, you also need internal inspectors. They have to inspect every single member once a year and then write reports about it. So you need people who can do this job and also to write these reports. And we thought it is possible if they create incentives, for example, school leavers in the community who are younger and have some kind of education to participate in the group, and then you can train them to do these literate jobs. Yeah. So if this would be feasible, then it is feasible. Yeah. And they also told me they have a lot of experience in group activities because they work as a groups, yeah, for a long time, and therefore in terms of that, they were very, yeah, they think it is feasible.
Okay, thank you very much. I have to cut this short here, and thank you again, Flora, for presentation and addressing the questions. And we're moving now to Maria at 3:30 now in the morning. And invite you to share your screen and to give us your presentation on livelihood and production strategies of smallholder livestock keepers in the Peruvian Andes, where you are right now. Floor is yours.
Okay, thank you. And hello, everybody. Yes, I'm going to present a small study that we did over a master student of us on looking into livelihood and production strategies for smallholder farmers in the central Peruvian Andes. So I will talk also about llamas and alpacas. And just to clarify, I mean the ruminant session, but they are not really ruminants, but pseudo-ruminants. So we know from historical data up to now that farmers in the Andes are confronted with economic and ecological challenges over the years. And the question is, how can farmers respond to these challenges? So one strategy is to balance between on-farm and non-farm activities. So partly work on-farm, but also generate income from non-farm activities. And the other question is the production strategy on farm. So do farmers go more into diversification, having different species on their farm, or do they actually focus on one specific species and go more for a specialization in their production system? So the study objectives were first to describe the importance of livestock production, compare it to non-farm activities for looking at the share for the household income. Then we looked also in the livestock production strategies, and we also looked into farmers' perceptions on climate change, as we know that the Andes are quite heavily affected by our climate change, and so we wanted to see how farmers can perceive it and which strategies they follow. So we did a study in the central Andes of Peru in the Pasco region. So you see on the map of Peru, a yellow region. So here is Lima. So it's about 8 hours drive from Lima. And we interviewed in total 46 persons, farmers. And we had 2 study regions. So we had here study region 1 around the city of Pasco, Cerro de Pasco. So it's a very high up. It's on above 4,000 meters above sea level. And we did another survey in the region of Daniel Carrion, which is a region which is on lower altitude and has a more favorable climate, and it's also favorable for agriculture. So comparing looking just first on the importance of livestock, we see comparing the zone 1 and zone 2, just focusing on who is completely dependent only on livestock and who has a very large share of livestock production, we see actually that in zone 2, which is, just remind you, is the zone which is at lower level, a quite high percentage of people dedicating their income or generating their income from livestock production, versus in zone 1, which is the higher altitude region, it's actually a bit less. So they obviously have also different strategies to generate income. So what they do is there's a region which is very well known in Peru for mining industry. So quite a lot of these farmers partly generate income by finding job opportunities in the mining industry. As I already mentioned, we have actually different species on these farms. So we see llamas, alpaca, sheep, and cattle. And all of these animals are kept for meat. Fiber production is mainly from alpaca and sheep, although for sheep it's declining as the wool price for sheep wool, as it's very coarse, is dropping quite a lot. Cattle are mainly kept for milk. Manure was also used by farmers, and llamas are the only ones that are kept also for pack as animals for carrying goods. So this is still quite an important function of llamas in these production systems. Looking into, do farmers diversify or go for specialization? But what you see in this table, we had farmers keeping all 4 species, quite a large number, 17. And that's mostly in the lowland area, compared lower region in zone 2, due to better climatic conditions, more forage production, just better access also to local markets. But overall, we can see that our diversification is the way farmers are going. So specialization is actually not a strategy that farmers are following. So what we also asked them to assess were herd dynamics in the past 5 to 10 years. And what we can see here, and also ask them what are reasons behind these dynamics, why they keep these animals. And we see for llamas, the tendency is more or less, it's a bit fluctuating, but it's more or less staying average, like maintaining llama herds. Llamas, although they have markets is very difficult due to selling llama meat, which is very difficult but they are, due to their very robust nature, so they are very liked by farmers because they don't need a lot of care and can easily be managed. So they still keep llamas kind of a backup. In the last years, alpaca herd numbers increased quite a lot, mentioned by many farmers, due to the very well price, and there were quite a lot of initiatives also from regional and national government to increase alpaca population. Sheep, there's then definitely a decline that's also backed up by the national census. We see a huge decline in sheep production due to the loss of the wool market. And cattle, it's stable and declining, and that many farmers said they are getting out of cattle production due to climate change, as forage production is getting more unreliable. So looking at the data, how farmers perceive climate change, they observed lower temperatures, shift in seasons, and also changes in precipitation. They perceived effects they could assess were increased mortality, lower productivity. 60% of the farmers actually tried to apply strategies to support their animals. but actually financial constraints was the main constraint for implementing different measurements. So how do farmers see their future? Actually, they are quite concerned due to uncertain market conditions and climate situation, and are actually thinking about changing income strategies. And actually the trend is going out of farming, and migration to urban region is seen as one option. So to conclude, our farmers see livestock diversity as a strategy to increase their resilience, so they can better respond to different market changes. And non-farm activities combined with livestock farming is actually quite important, and it's expected to rise in the future. So with this, I would like to conclude my presentation and thank for your attention.
Thank you very much, Maria. And the floor is open for questions. Yes, Marion, welcome.
Yes. I'm just curious about what you said, that they see moving to the city as an option. Is it also a difference between the generation? Like the younger people would be more interested to work in the cities, they are less interested in farming, or is it also older people who are farming since many years?
Well, also old farmers are working already in the mining industry. So because mining is there already for a very long time. So, but that means they stay still in the region and can work for a couple of days in the mining industry and then go for a few days home. And meanwhile, somebody takes care of the animals. Going out migration to going to Lima, that is also quite frequently by everybody, but more tendency for younger people. So it is actually a question. So like the alpaca industry, they are worried who will do alpaca farming in the next generations, because people don't see, well, bad infrastructure, all the usual problems that we know from rural areas is not really favoring people to stay.
Mm-hmm. Any other questions? That is not the case here, but Marvin Hoyduk, one of the online participants, Maria apparently knows him. Hope you are doing well in Peru. Is there a connection between focus on diversification or specialization and the percentage of livestock production to the total income? Did you get that?
Well, if I understood him correctly, he wanted to see if if more diversification contributes to more income.
Yeah.
So like most farmers, basically all are diversified. So it's not, so how would I say? Those who have more cattle, they have more income from livestock.
I understand the question as though there's two possible ways. Either you diversify or you specialize. Huh? So,
Yeah.
and now who of them, the diversification or the specialization person, who of them has the higher share of livestock income in total household income?
The more diversified, they produce more, so they have more income from livestock.
Mm-hmm. The more diversified have more income from livestock. That, I mean, that is something that is maybe an indication that there is not really a high price product involved in livestock. Everything is sort of equal. Because if I think alpaca fiber, for example, there is a niche market that usually also pays high prices, but only if you can deliver a very high quality of product, for which you need to be a very specialized or have a very specialized system so that you can guarantee the quality.
The alpaca fiber is extreme. The price depends on the world market, and it's extremely volatile.
Okay.
So it's farmers and alpacas increased a lot in this region. It's as I said, it was driven by extremely good prices, and it was supported by quite a lot of initiatives. But still, farmers are not going strictly for alpacas only.
Okay.
To back up for this fluctuation. And they also require different feeding compared to llamas. So llamas are always there because they just, if it's getting drier, they have the better advantage of needs compared to alpacas. Llamas are still more robust and easier to manage.
Exactly. Yeah, thanks. And the last online question here, what happens to farms when they give up their animals and farming? Asked by Andrea Fadani again. So if people drop out of farming, what happens then? Not with the people, but with the farms.
Yeah, good question. We did not ask that, but I would assume it's like it's usually then neighbors take to some extent use lands then. So, or it's also sometimes, usually they still keep some linkages to their homesteads. So sometimes it's that neighbors then take care of animals.
Yes, I mean, here in Europe, farmers are secretly very happy if their neighbor drops out of farming, because then they can get hold of the land and increase their farm size.
Yeah.
Difficult question. I have to stop the discussion here, otherwise we won't have enough time for Salma. And now, thank you very much, Maria, for your presentation and for answering the questions. And I now invite Salma El-Zaki to share her presentation with us and start talking on genomic loci affecting somatic cell spore in a Butana and Holstein crossbred population. And she'll take us to Sudan. It's all yours, Salma.
Yeah, thank you very much. Thank you for this introduction. And hello everyone. My name is Salma Zaki. I'm lecturer at the University of Khartoum, Faculty of Animal Production, Department of Genetics and Animal Breeding. Now I'm a PhD student at Cambridge University. Let me share my screen. Can you see? Hello?
Not yet. I see that you, now. And if you now choose the presentation mode.
No.
Yes. There we go.
Yeah, welcome to my talk, Genomic Loci Affecting Somatic Cell Spore in Butana, Holstein, crossbred population in Sudan. First, I will introduce my investigative fields. And as we know, livestock in Sudan play an important central role in the production of food. And Sudan possesses Sudan cattle population estimated about 42 million heads. Butana cattle constitute about 24% of the cattle population in Sudan and considered as the main dairy cattle breed of Sudan. Botanic cattle is classified as a post-indicative cattle breed, which inhabits the Botanic area in the east of the Blue Nile and have spread to zero in the central Sudan and also spread along the River Nile in the northern region of Sudan. The milk production is around 1,200 to 1,800 kilogram in average lactation length of 240 days, with 4.9 fat content, 3.9 protein content, and this feed is well adapted to hot climate, harsh environment with low feed availability, lack of water, and resistant tropical disease and parasites. And the improvement of milk production is a major social, economic, and cultural goal of Sudanese government to ensure sufficient and healthy nutrition and to increase income in the rural areas. And when the demand of the milk production, milk and milk products increase, therefore we need to improve milk production. Currently, milk production in the big cities mainly from crossbred cattle, and crossbred cattle can be now found in all the country, even in the rural areas. Usually, botanic cattle crossed with imported hybrid, such as Holstein, and the milk production of this cross is 3 times of Botana, with less fat content and less protein content. This cross is adapted to hot climate and adapted also to tropical disease and parasites. The big problem in all farms in Sudan is mastitis. Mastitis is considered as one of the main milk production problems. Mastitis is inflammatory disease. It's one or more other part. Mastitis is one of the costly disease due to economic losses by reduced milk production and reduced milk quality, increased treatment cost, and color. Mastitis is the result of interaction between individual genotype, pathogen, and environment. Mastitis can be detected using somatic cell count, and somatic cell count is somatic cell in 1 ml of milk. Somatic cell count is an important component in the assessment of milk quality, hygiene, and mastitis control. Somatic cell count can be used as an indicator to other health, and also considered as a useful predictor for intramural infection. And the final data set of somatic cell count will transform into somatic cell score using this equation to obtain a normal distribution that's closer to the normal. Somatic cell score can be used as for genomic selection. The objective of this study is to identify genomic loci affecting somatic cell score in Botana, cattle, and in crossbred population, using previously identified genetic marker for mastitis cell for somatic cell count in Holstein population. And here in this figure we show it the genome-wide association study in a previous study, and show it the significant SNPs in associated with somatic cell score in Holstein population. Material method: 93 animal samples from purebred botanic cattle were collected from a small order from different geographical regions in North Sudan, and 203 cows from crossbred population were collected from 5 farms from Fulton North. Phenotypic and genotypic data. For phenotypic data, somatic cell score were measured using microscopic slide method from monthly milk samples, and the final data set was transformed to somatic cell score. Blood samples were collected from annotated animal, and DNA was extracted. Allele-specific genotyping for 10 SNPs using Casper stain. And these SNPs are located on 6 genomic regions on chromosome 5, 6, 13, 18, 19, and X chromosome, and these SNPs are previously reported to be associated with somatic cell score. Association analysis between genotypic and phenotypic data were performed in botanic cattle and in crossbred population, and Data were analyzed using linear mixed model implemented in R language for statistical computer version 3.5.3, and the final model including the population mean, animal as a random effect, vector of the significant fixed effect, and SNP genotype and error. The results. First, we have the mean somatic cell count across breed. In general, we have here six parts, 5 from crossbred population and 1 from botanical. In general, the somatic cell count is high in all our population, and as you can see, all the somatic cell score above 5, and here in Germany, if there is a somatic cell count more than 5, the milk will not sold. And this is a major problem of the Sudanese government. Here, if you see, is the somatic cell score observed in botanical as lower compared with crossbred population, and high variation of the somatic cell score observed in crossbred population. P-values of the cofactors affecting somatic cell count. We tested the cofactors lactation number, calving season, calving year, birth year, age at first calving, days in milk and farm. And we find that in calving year, birth year, and age at the first calving significantly associated with somatic cell count in Botana cattle. And we found that calving year and age at first calving associated with somatic cell count in crossbred population, and farm was suggested to be associated with somatic cell count in crossbred population. Here in this slide, we have an association between Here in this slide, we have an association with somatic cell count in botanical, and in botanical, we found that 6 SNPs were not segregated, and there is no association between the tested SNP and somatic cell count in purebred botana cattle. And if we see here in this table, we found that one SNP located in chromosome X is significantly associated with somatic cell count in crossbred population, and 2 SNPs is not significantly associated, but may be associated with somatic cell score, and here we need to follow or validation these SNPs in big population. The summary of this study in botanical, we found that birth year, calving year, and age of the first calving associated with somatic cell score, and only 4 out of 10 SNPs were found to be segregated in the population, and no association found between tested SNPs and somatic cell score. In crossbred population, we found that birth year, calving year is significantly associated with somatic cell score, and one SNP located in chromosome X significantly associated with somatic cell score, and 2 SNPs located in chromosome X 6 and 19 showed a non-significant but weak association, and here we need to follow up the study a bigger population. Thank you for your attention.
Thank you very much, Tama. And the floor is open for questions, and I see Zeyi has already unmuted his microphone, so fire away, please.
Okay, thank you very much. I'm glad to start with your conclusion, Salma. You said that the SNPs that you found on chromosome S may be used for genetic improvement.
Yeah.
How do you think that is possible?
Yeah, we find only one chromosome located on chromosome X is associated with somatic cell count in crossbred population, and also we found that this SNPs is also associated with somatic cell count in Holstein Friesian, and this is unpublished data until now. And when we search in the candidate gene in this region, we found that there is a gene called IGFIR. This SNPs, this gene is previously reported to be associated with mastitis resistance and also associated with somatic cell count. So we can use these SNPs for genomic selection to improve resistant to mastitis and to improve resistance to somatic cell score.
Okay, thank you. But do you know whether there is other consequence of this gene or SNPs on other production performances or on the animals in general? The effect of these SNPs, have you in the literature, is there anything about it?
No, because normally when we increase the milk production, this you will have a disadvantage for increased mastitis resistance. But in this case, no, we didn't find anything. Yeah, and so we can use it to improve the mastitis resistance in our population.
Okay, sorry, one question again, but you said that somatic cell score is high in the crossbreed.
Yeah, compared with
How can you explain also that if we also find one gene on SNPs that are associated?
Could you repeat your question? Sorry.
I said you find that the somatic cell score is high in crossbreed.
Yeah.
And
yeah.
How can you explain that? That's clear?
No.
I mean, you said that the somatic cell score is high in crossbreed than the second breeds.
Mm-hmm.
So what may be the reason why it's high in these breeds and why?
Actually, because there is a relationship between the production and the mastitis. When the production increases, automatically the mastitis and the somatic cell count will increase, and the production for this breed is more than the production for our breed or for purebred botanically. So this may be one, and also there is a variation in the somatic cell count in this crossbred population between farms, and also farm was showing a significant association with somatic cell count, and this variation may be due to production, maybe due to blood percentage from different blood percentage, and also maybe due to management practice.
Okay, yes, that was what I was thinking about. Thank you.
I have again an online question from Dr. Fadani. It would be nice to combine this interesting research with an economic analysis on the breeds. Will Sudanese farmers keep these indigenous cattle, or will they go for the crossbreeds if they want to produce milk? What is your take on that?
Yeah, actually, this is a big problem now in Sudan. All farmers thinking about only crossbreed because they are thinking about the profit of their cattle. And when we compare between the production from our breed, purebred botanic cattle, and crossbred population, we found that crossbreed it give more profit and more milk production 3 times compared with purebred botanic cattle. But the record starts and there is no records in the farm, and all farms, and this is a problem now because we found this crossbred even in the rural areas. So we need to conserve the purebred botanic cattle, and after that we need to improve their productivity. And
I have myself a similar question to you that I had already to see. Your farmers in Sudan, do they know which of their animals has good udder health and which has worse udder healths? Which ones are the ones prone to mastitis and which ones are not? And what do they look at? You are looking at SNPs to find out where is good udder health and how heritable is it. What do the farmers look at?
Yeah, the farmer look at the phenotypic. When we go to the farm, they directly say to you, this cow is good milk production and is resistant with for somatic cell count and mastitis. And the farmers in Sudan know everything about their cattle.
So apparently they see something that you need a sophisticated scientific method to also see it. Is that true?
Yeah.
And now my question would be, for maybe for a future research, do the farmers have the ability to see that? They have the ability to see that in their Bhutan cattle. But is their ability to see that as well developed also for the crossbred cattle?
Sorry, could you repeat your question? Sorry.
Yeah. I mean, your farmers can, I assume, your farmers would see and know very well which of their Bhutan cattle have good udder health, produce a lot of milk, have low cell counts, etc., etc. Can they see that in the crossbred cattle as well, or as good as in the Bhutan cattle?
No.
Why not?
They see that in the purebred botanic cattle only, but they used to or they apply or they thinking about the crossbred cattle because only for the high milk production, and only at this time we thinking about the profit of the farm. But when we compare between botanic cattle and between crossbred population in regard to adaptability and in regard to milk production and milk quality, the botanic cattle is the best.
So,
but we will apply these techniques and we'll apply this in the research station in North Sudan, and we will distribute the result from other farm.
Yes, very interesting. I could, as in all your topics, I could continue for at least another session long discussing, but we are 12:07. I have no more online questions. I would allow one last question here from the floor if there were any, but there isn't. Marion, come on.
Yeah, if I may, then it would be a question to you, Flora, because I was really interested with your idea of supporting organic production, but because you say that the local breed have higher meat. So do they already have a system in place for the breeding? I mean, because you also said that they are in a group, that they sell the animals and they support each other and so on. But for the breeding also, I mean, you need the identification, and wouldn't be, maybe it's simpler to support the breeding of the animal rather than to make it organic? Or I don't know if you looked at that or if it's...
Okay, so the animals are preferred in the livestock market because of their taste. So they have a very good taste. And this is also, of course, because of the breed, but also because of the feeding, because they are grazing on salty pasture and drink salty water, and therefore the meat gets a special taste. And these breeds are very good adapted to that conditions. So the groups tried other breeds, and they also looked for improvement, but they don't want to change the actual situation in terms of genetics because they are so good adapted to that conditions. So our study was more about the marketing and not about the breeding, and I think that is also a good way to help the people to yeah, to have an advantage from their livestock production.
Yeah. Okay, thank you very much. I need to cut it short now because we have to quit this stream channel, probably. We are having Ruminant Systems poster sessions this afternoon. One is at 5 o'clock in the afternoon and one at 6 o'clock in the afternoon. So for all those interested in ruminants and pseudo-ruminants, please be there again. And I say also thank you to all the attendants on the YouTube live stream. And I hope to see you all back this afternoon. And please use the possibilities that the Wova platform gives you to continue interacting with each other. You can, under the community tab, you can start chats on topics. If you have not yet figured out, go and try it. Thank you very much for all your contributions and your discussion. Bye.
Thank you.
So.